This is problem 3 of Standard 8 GC9, where we are using the formulas for volume of a cylinder, sphere, and cone to solve real-life and mathematical problems to find their volume. On problem 3, in the diagram below, the cone. Notice it's a cone. It's got a circle at the bottom, circular base, and it comes up to a tip at the top. The cone has a radius of 9. See, halfway across the circle is 9, and a slant height of 15. Here's the height here. That's not the actual height. The actual height of the cone is right here, from the top, tippy top, down to the center of the bottom. They want the volume of the cone. We know the volume of a cone. If you had a cylinder, we talked about how you get to the formula for the volume of a cylinder. If you've got a cylinder, when you've got two bases that are congruent, your volume is equal to the area of the base times the height. This base is a circle. The area of a circle is pi r squared, so we substitute that in place of this area of the base times your height. There's your volume for a cylinder. But this is not a cylinder. We talked about a cone. If you take a cylinder and you take the cone out of it, that's 1/3. See, I got two sections over here. That would be, your volume is 1/3 the volume of the cylinder, 1/3 pi r squared h. Volume is 1/3 pi r squared h. You can look this up on your formula sheet. If I've got the situation, I need to substitute in what I'm looking for, or what I have. I'm looking for the volume. That's 1/3, and look, pi is in the answer, so we're not gonna substitute anything in place of pi. Our radius is 9. Our height, we don't have our height. Look, we've got a right triangle here, don't we? Let's draw this off. Yeah. Sometimes when you're doing this and you're dealing with cones, and sometimes even with cylinders, they're going to use, or even sometimes with spheres, they're going to use the Pythagorean theorem to find a side and a right triangle that's cut into one of these figures. Notice we've got a right triangle. Okay, so I can use the Pythagorean theorem to find this missing side. If I'm looking for it using Pythagorean theorem, let's come here. A squared plus b squared is equal to c squared. I need to find which side would be c. It would be across from the right angle. Your c is always the long side of the hypotenuse, across from the right angle. Then it doesn't matter which one of these is a and which one's b after that. C is the only one that matters. So in place of the c, in place of the a, I'm going to put my height. In place of the b, I'm going to put the 9 for this side. In place of the c, I'm going to put the 15. I have substituted those in. H squared plus, and 9 squared is 81. 15 squared is 225. I'm solving for h squared, so I need to subtract 81 from both sides. Let's say 225 minus 81. That would give me 144. H squared is equal to, let's put my square there, 144. I'm not looking for h squared, I'm looking for h. So let's take the square root of h squared to get to h. What I do to one side of an equal side, I have to do to the other. H then is 12. 12 centimeters. This height is 12 centimeters. We've got to plug it in for this h where we were looking for it. 12, okay? Now we use our calculator and we get our answer. Remember, we're not going to use the pi because pi is in the answer. I'm going to do 1/3 of 9 squared, which is 81 times 12. And that would give me 324 times pi. 324 times pi. That's the exact answer because I didn't multiply by approximation of pi. There's my answer, 324 pi. That's the volume.